And we're back. I wanted to take a look at the last couple of examples from our notes file. So, go ahead and flip to the last page if you haven't already, or, page to it in Adobe Acrobat or whatever you're using to view it. You get the idea. So each of these problems deals with an exponential equation, and then we ask you a couple of things to do with it. In each instance, there's one problem we ask you to do that doesn't require any logarithms or anything. You can more or less, I hate to use this phrase, but plug and chug. I'll talk about that as we go, but I want to focus on where we actually need the logarithm type stuff in order to solve what we're after. So we're dealing with a sales situation. So they've had an ad campaign going on, and they're wanting to look at how sales are going to tail off over time. So we have an equation modeling that looks like the following. Double checking to making sure I've got the right number of zeros. I do, in point of fact. 100,000 e to the negative 0.5x. As I am prone to do, I'll put the 0 in there so I don't risk losing my decimal point. So on the one hand, they ask us where sales are going to be 10 weeks after the campaign wraps up. That's what X is standing in for. I have high confidence you can plug X equals 10 into this thing and smash through the calculation to come up with a sales figure. The more interesting problem of the bunch is we want to know how long it's going to take for sales to tail off to under 400. So what I'm going to do is take that, feed it in for S, and then set that equal to the corresponding exponential side. Awesome. We want X by itself. Hopefully this feels familiar at this stage. What are we going to do? We need a log. Can we do it yet? Not the way we've been going at this. Let's get the exponential piece by himself first. Shabam. I left out a 0. 100,000 divided by, we're dividing both sides by 100,000. Slash. Okay. Those guys are gone. 400 divided by 100,000 would give me 0.004 if I'm doing my arithmetic right. Spoilers, I am. So, just like we've seen in the past couple of examples, let's take a natural log and then we'll be able to isolate X. So, ln 0.004 equals ln e to the negative 0.5x. Since this is a base E log, splat. The ln and the e both go bye-bye. We're left with negative 0.5x, and so now we just need to get x by itself via division. So we divide the natural log of 0.004. Sorry, I was trying to do some of the calculations in my head. That's dangerous. Divide that thing by negative 0.5. I got approximately 11.04 weeks. So 11 weeks come to a close and a little bit more. So I guess we go into a bit into the beginning of the 12th week before sales have tailed off. So that's one problem. Done. Awesome. Got one more to take a look at. We are in the home stretch of the chapter at this point. So let's take a look at that guy. I believe it's one where finally things are a little bit rosy. We've talked about, we just talked about sales going down. I guess that's bad. Let's talk about investments going up. That's good. So similar kind of setup to a problem from before. We've got $1,000. We put it into some sort of account. That is building interest. It says it's compounded continuously, so the idea there, we'll talk about this more in Chapter 6, is that as soon as any interest accrues, it gets rolled into the account and then starts building interest itself. Our annual interest rate is set at 10%, so we give you a formula to represent how much the account is worth T years after we make that initial deposit. So we have S equals 1,000 E to the 0.1 T. You could write 0.10, but the 0 at the end doesn't really change anything. So now we've got a variable T representing the number of years we've let the account cook, so to speak. And on the one hand, it asks us how much we've managed to build up after 1 year. That corresponds to T equals 1, plug it in, give me a number in the assignment in Moodle. On the other hand, we want to know how long it's going to take this investment to double. You may recall this doubling time thing from the last section. So hopefully you don't need me to tell you that doubling $1,000 would mean we have $2,000 sitting in the bank. So we feed in 2,000 for S. We want to get T by itself. Hopefully this sounds really, really familiar. Divide both sides by 1,000. I slashed through the guy prematurely, but so divide both sides by 1,000. It's gone from the right on the left. 2,000 divided by 1,000. We're going to have 2 over here. E to the 0.1t on the other side. Hopefully at this point this move is starting to feel really familiar. We're going to take a natural log of both sides of this thing. Natural log of 2. Natural log of e to the 0.1t. That same inverse property, ln of e to the something, gives us the something. One of my math professors when I was an undergraduate used to use examples always involving pumpkin pie. So the natural log of e to the pumpkin pie gave us back pumpkin pie. So that's all that's left. The only thing we need to do is get rid of this 0.1 sitting on our t variable. If you divide the natural log of 2 by 0.1, you should end up getting an investment time of 6.93 years before the investment doubles. So, hopefully you weren't hoping to have $2,000 before you get to your 7th anniversary of the investment account. So, achievement unlocked. We've completed Chapter 5. So next week, we'll start posting content on Chapter 6. We're also, because it's class, this is the sort of thing we do, we're going to have a test on this going forward. So stay tuned for announcements on that. Good luck with the rest of the content. Don't hesitate to reach out to me with questions, and I will see you next time.